Good morning. Today we are going to discuss the problems of the exercise 1.2. In the last lesson, we have discussed the concept of function, and I hope that you all have gone through it. And today I will be doing the problems in the questions of exercise 1.2. In the first question, it is given that show that the function f from R to R defined as f of x is equal to 1 by x is 1 1 and on 2. And the second part of the question is where R star is the set of all non-zero real numbers. This is the first part of the question. The second part of the question is the real true if the domain R is replaced by n with codomain being same as R plus. See the now first part. The given function is f from R star to R star such as f of x is equal to 1 by x. Then now first of all we prove that for 1 1. If you remember, let f of x is equal to f of y, and then I am going to prove that x is equal to y. F of x is equal to f of y, it means what? F of x is equal to 1 by x is equal to 1 by y. It implies that x is equal to y. F of x is equal to f of y we supposed, and now we are proving that x is equal to y, and hence it is 1 1. Right? Now for onto. For onto, let y belongs to codomain of f. Codomain of f. Or I can write y belongs to codomain of f is y belongs to R star. And you know that y is equal to f of x. Therefore, y is equal to f of x is equal to 1 by x. It implies that x is equal to 1 by y. X is equal to 1 by y, where x belongs to domain of f, and therefore x is equal to 1 by y. Now I'll go and I'll show that y in the codomain of f, and for every y belongs to codomain of f, now I can write for every y belongs to R plus, there exists a unique pre-image in the domain of f, and hence it is onto. Right? Or I can write in other way also. Suppose if I'll find out f of x, then I'll put the value of here f of x is equal to 1 by x, and 1 by y is equal to, I'll get y. Isn't it? That is this part, instead of writing, if we need to write the language, we'll write like this. Or if you want to prove it, for proving I can write now f of x is equal to 1 by y. Now 1 by y will be replaced by 1 by x. So y 1 by x will get what? X. The f of x is equal to x I am getting. And therefore, for every y belongs to codomain of f, there exists a unique pre-image in the domain of f, and hence it is onto. The first part is done. Now I will go for the second part. Right. Now for the second part, for 1 1, same way we have to go for it. Let f of x equal to f of y, 1 by x equal to 1 by y, it implies that x is equal to y, and hence it is 1 1. For the second part, onto, let y belongs to the codomain of f, and x belongs to natural number n. See, in the second part, the domain has been changed by R plus to natural number n. Now x belongs to n such that now y is equal to f of x. The y is equal to f of x is defined as 1 by x. So now x is equal to 1 by y. Now 1 by y may not be a natural number. That is, if I take y is equal to 7, if I take y is equal to 7, if I take y is equal to 5, if I take y is equal to 3, then here if y is equal to 7, then x is equal to 1 by 7, and 1 by 7 is not a natural number. That means its pre-image is not present in the domain of f, and hence f is not onto. This is the first question which I have solved. Now in the second question, there are 5 parts, and for each part we have to check whether the function is injectivity or surjective or not. I think if you remember, injective means what? 1 1, and surjective is the another name for onto. That means we have to check the given function is 1 1 or onto. Out of these 5 parts, I will be doing any 1 or 2 part of these questions, right? Now in the second part of the question, the first function is given as f. Second part, first part of the question, f is from natural number to natural number n, such that f is defined as f of x is equal to x square. F of x is equal to x square, right? For 1 1, let x1 comma x2 belongs to n. That means f of x1 is equal to f of x2. F of x1 is equal to x1 square is equal to x2 square. It implies that x1 square minus x2 square equal to 0. It implies that x1 minus x2 and x1 plus x2 equal to 0. It implies that x1 is equal to x2 provided x1 minus x2 is equal to 0. That is, f of x1 is equal to f of x2. It implies that x1 is equal to x2, and hence f is 1 1. Fine. Now the second part, for onto. For onto. Now for onto, okay. F let 3 belongs to n. 3 belongs to n. Now when 3 belongs to n, then f of x is equal to 3. F of x is equal to 3, because the given function is, we have function f of x is equal to x square. F of x is equal to x square. And now I have taken that x belongs to n. That means x is equal to how much? Root 3. Then only I will get 3 here. That means if x is equal to root 3, x is equal to root 3 if I put, then only I will get here 3. That means now x is equal to root 3, which does not belong to the set of natural numbers. Isn't it? Therefore, there are so many numbers whose pre-image is not present in the domain of f, and hence it is not onto. It is very, very important to remember, whenever you are supposed to prove it is 1 1 and onto, then you go for the usual method. But whenever you are supposed to prove it is not onto, then you have to think, and then you have to find out any example by through which we can write yes, it is not onto or 1 1. Fine. Here I have taken only 3. You can take any number, because if I take here 5, then f of x is equal to 5. That means x is equal to under root 5. Again, under root 5 does not belong to the domain of this f, and therefore I can write here also that for each and every x belongs to the codomain of f, there does not exist their pre-image in the domain of f, and hence it is not onto. This is the first part of the questions. Now after this, I will bring one more part of this question. Suppose I am going to the second part of this question, right? In the second part of this question, f of x equal to x square integer है ना? Second part, f is a function from z to z. It is f of x equal to x square. क्या बंद है ना? Right? Now f is a function from z to z given by f of x is equal to x square. If for 1 1 for 1 1, if I go for the usual method, it can be proved, because right now we have proved the first question, that f of x is equal to x square, where the function was defined from natural number to natural number, but here it is integer. Now it is not on 1 1 function, because if I z 1 belong, f of 1 is also 1, f of minus 1 is also 1, because the f of 1 is equal to 1 square is equal to 1, f of minus 1 is equal to minus 1 square is equal to also 1. Now see, there are two elements having same image in the codomain of f. Therefore, let 1 comma minus 1 belongs to z, and f of 1 is equal to 1, f of minus 1 is equal to 1. Therefore, there are so many numbers in the domain of f having same image in the codomain of f. Instead of writing this much, we can write simply, yes, f of 1 is equal to 1, f of minus 1 is equal to 1. That means there is no unique image in the domain of f, and hence it is not 1 1. Right? Now the second part will prove, for it is onto. Right? For onto. Right? For onto. For onto, z is an integer. Now let minus 1 belongs to codomain of f. Yes or no? It is possible. Minus 1 belongs to codomain of f. So now f of x is equal to minus 1. That means f of x is equal to minus 1. It implies that x square is equal to minus 1. It implies that x is equal to under root minus 1. Now this under root minus 1 does not belong to the what? To the integer, set of integer z, and that's why, therefore, for each and every element of codomain does not have a unique pre-image in the domain of f, and hence it is not onto, or it is not, another name, do you remember? Surjective. 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 See, the same function which I discussed with f of x equal to x square, when it was natural number to natural number, it was 1 1 and onto both. But when it is f of x equal to x square, function is same, but the domain and codomain has changed with the integers. Now it is not 1 1, not onto. That's why I hope that second part also I have done. Third part, fourth part and fifth part you all can do yourself. And now I'll go for some other question. Right. Now I hope that you can do the rest of the questions of the second question. There are, I think, 5 parts are there. Third question I left for you. Now the question number 4th. So that the modulus function, you know that f of x is equal to mod x. Mod x is equal to, I can write x where x is greater than or equal to 0 when x is positive, and minus x when x is less than 0. Now for 1 1, when x is less than 0, f of minus 1 is equal to 1, and f of when x is greater than 0, then f of 1 is equal to 1. Therefore, what we see over here, that minus 1 is not equal to 1, but 1 is equal to 1. It means what? Why I have taken now that x1 is not equal to x2, but f of x1 is equal to f of x2. Minus 1 is not equal to 1, but f of x1 is equal to f of x2. That means I can say that, other way I can say that f of minus 1 is also 1, right, and f of 1 is also 1. That means there are two elements having same image in the domain of f, right, and that's why it is not 1 1 or it is not injective. For the second part, onto, let minus 1 belongs to codomain of f. Minus 1 belongs to codomain of f. Now, codomain of f has the elements mod of x, right, and the mod of x is always positive, non-negative numbers. Non-negative numbers. It means there is no element in the codomain of f whose pre-image is present in the domain of f, and hence it is not onto also. Fine. Right. After this question number 4th, I hope should I go for question number 6? Now I will do question number 6. Now we will go for question number 6. In the question number 6, it is given that a is equal to 1 2 3, a is equal to 1 2 3, b is equal to 4 5 6 7, b is equal to 4 5 6 and 7, and the given function f is given as 1 4 2 5 3 6, right, be a function from a to b so that f is 1 1. Now see, a has the elements 1 2 3, b has the element 4 5 6 7. From f is a rule from a to b. Now f is given as 1 4, that means the f image of 1 is 4, f image of 2 is 5, f image of 3 is 6, right. Now if I ask you which type of function it is, you can say it is 1 1 into. Why it is into? Because there is one element 7 whose pre-image is not present in the set A. That's why it is 1 1 into. Now you have to check whether it is 1 1 or not. The question is this, so that it is f is 1 1. Of course it is 1 1 because see f of 1 is equal to 4. Right, f of 1 is equal to 4, f of 2 is equal to 5 and f of 3 is equal to 6. Now see, 1 is not equal to 2 is not equal to 3, but at the same time 4 is not equal to 5 is not equal to 6. That means for different elements of A, there is different pre-image in the codomain of f, and hence the function f is 1 1 or f is injective, right? Now I hope and I wish that you can do the questions of this exercise, and rest of the questions I hope that same way for probing 1 1 or on 2, same process we have to follow for each and every questions. Please you try your level best, and better you send your solution to my drive also so that I can check, and if you have any difficulty you can ask me. Thank you very much, and I'll